Greetings! Today we are looking at the cotangent graph, where we want to take a look at f of x, or f of theta, equals the cotan of theta, and we want to try and make a picture of that. Okay, so some things to know. Cotan is your reciprocal function of the tangent, okay, which means we are going to have cosine theta over sine theta. And in terms of coordinates from your old pal, the unit circle, that means we're doing x over y. So I've got your quadrantal coordinates marked on the unit circle. So if we take a quick look here, if we put x over y, we're going to end up over here at 1 over 0. Okay, we're going to have 0 over 1, negative 1 over 0, and typo at the bottom, typo, handwritten, oopsie. All right, let's put this guy down here at 0, negative 1, so we have 0 over negative 1. That's a little better. Okay, so then how does that look when we do our thetas in radians and decimals going across with our coordinates? Okay, so I added this negative pi over 2 again, like I did for the tangent graph, just so we could back up one, and you'll see why here in a second. So at negative pi over 2, we have a 0. Okay, right here. At 0, we have undefined. Okay, and just in a similar fashion to tangent, the sign is going to give us place we have to pay attention. We cannot have zeros in that denominator. All right, cotan of pi over 2. A pi there is 0. At pi, we are undefined. 3 pi over 2 there at 4.71, we have a 0. And then all the way back home, we are at undefined. All right, same as our tangent graph, the period for cotan is going to be pi, because we have a repeated pattern happening, okay, at the pi. All right, so let's take a look at this graph. Okay, I'm going to put on our undefined, so I'm going to mark our asymptotes first. Okay, so at 0, we have an asymptote. At pi, or 3.14, we have an asymptote. And then again at 6.28, we have an asymptote. And if you think about those asymptotes, those are in fact the zeros of your sine graph, of which we've done many of those at this point. Okay, so then what? The zeros for the cotangent are going to happen at pi over 2. Okay, let me switch colors here. All right, so now I'm looking here at the zeros. Actually, we could start at negative pi over 2. So negative 1.57. I'm going to back up here. We're just about out of room. Positive 1.57. 4.71. Okay, those are our zeros. Okay, and then this time, our graph, instead of being increasing, the cotan's going to be decreasing. In fact, we can make a little note of that. This guy is decreasing as we follow those lovely asymptotes. Okay, so we'll start up here, come down and across. There we go. Okay, these are cotan curves. Okay, and this one would start down and go that way. This one we see the upper part. Whoopsie. Don't even know what that was. Okay, better yet, let's just turn this, we'll just get rid of that. Pretend I didn't draw that side. Okay, that'll work. So we should be coming across and down this way. There we go. Okay, so that's our cotangent graph, just the basics. Okay, just the basics. Periods, pi, and there we go. All right, it seems to me I have a second grid here. Let's see what looks like fun. How about we do something like this? F of x equals cotan, and this time let's do x plus 1. Okay, so if you think of your transformations, since we have that plus 1 in the quantity, okay, which way is that going to shift? Yay, you are correct. That is going to be a shift left 1. Okay, so if we think about our graph, if it's following sine for the asymptotes, okay, all those asymptotes lines now are going to shift to the right 1. So instead of at 0, like on this previous one up here, we're going to go to the right 1. Okay, so we'll have an asymptote at 1. Instead of at pi, right here, we're going to the right 1. Okay, so 4.14. Okay, and again here, instead of at 6.28, we will be at 7.28. All right, for your asymptotes. All right, then we got to shift our zeros. Okay, so the zeros, everybody, oh my gosh, I know how I can fix this. I went to the right 1, didn't I? I had another example I'm going to do. Okay, so let's see if it'll let me do this. All right, Miss Highland is going to change the example because I don't want to start my whole set of notes over. I told you I don't like to do that. All right, let's say this said x minus 1. And I know if you're watching, you're saying, you are such a big cheater. You're right, I am. All right, so this means to the right 1. I don't know why I had that in my head. I guess because it's a Friday when I'm videoing. All right, so anyway, I took all the asymptotes and I shifted them all to the right 1. All right, so now we're back on track. I just had to change my equation. All right, so that means all the zeros have to shift to the right 1. So instead of being up here at 1.57, I'll be over at 2.57. 4.71 will be at 5.71. Okay? And then from there, I can go right ahead and draw that cotangent graph. Okay? So it is still a decreasing graph. Coming down here to the 0. Okay? Coming down to the 0. Okay? Period is still pi. Nothing changed there. Period is still pi, just like before. I guess I could have thrown on an extra 0 on the back side. We were what, 1.57 negative, so we were now at about 0.57. Let's see if we get this in here again, and we will drop this guy into this side. Okay, and somewhere up here, we'd have the start of another one. Okay, all right, sorry about that little faux pas in the equation, but we got it fixed up. I just changed it and made it shift to the right. I guess I felt like going to the right today. All right, kiddos, I hope you have a great time with your cotangent graph. Catch you later.